Okay, so now let's just solve few of the questions where we are actually solving system of linear equation, which means that it will be given that ax equal to 0 or ax equal to b, like this is called homogeneous, or this is also called now let's just solve few of the questions. So we will be solving for system of linear equations. Now this is the first time where we will be actually solving system of linear equations. Okay, so if we write ax equal to 0, then this kind of equations are called homogeneous. If we write ax equal to b, then this kind of equations are called non-homogeneous or heterogeneous. Like non-homogeneous is also one popular word that you can use. Okay, so non-homogeneous or heterogeneous. So we will be using non-homogeneous much often. Now, for our purpose, actually, we will not be differentiating between whether it is x equal to 0 or x equal to b. So, whatever way we are going to use, that will be applicable for either x equal to 0 or x equal to b. There is no difference between x equal to 0 or x equal to b for our purpose. Okay. So, let's just solve this question. So, this is the question number 1. And then, let's just see what they are asking. They are saying solve the system of linear equations using Gaussian reduction or Gaussian elimination. So, we want to solve this using Gaussian elimination. That's the problem that they are asking. Now what we can do, we can just copy this on the next page. Okay, and then I can just solve here. So let me first represent this set of equations into augmented form, which means it will be 1 1 minus 1, and then 1 minus 1 1, and then 2 minus 1 minus 1, and here you will be writing 0 2 minus 3, right? This is the matrix form of this equation, this set of equations. Now what you can do, you can just convert this into echelon form. So below this one, write all the zeros, which means that you need to replace this R2 by R2 minus R1. Similarly, you need to replace this R3 by R3 minus 2R1. So that is the one equation that you can use, and by which you will be making these two zeros. So let's just make these two zeros. What you will be having is this. This is 1, 1 minus 1, and then this is 0. Now it will be 0 because R2 is going to replace by R2 minus R1. So R2 minus R1, so it will be minus 2. It will be 2, and then it will be 2. And R3 is going to replace by R3 minus 2R2. So basically you are going to replace this by 2 minus 2R2, which means it is 0. Now you are going to replace this minus 1 minus 1. This is minus 2, right? Sorry, this R3 is minus 1, and then 2R1 is 2. So this will be minus 3. And then minus 1 plus 2, that will be plus 1. And then minus 3 minus 0, that will be minus 3. So this is what you are getting. Now you notice one thing, that all of these are 0 now, right? All of these are 0. If there is any calculation mistake, you can just comment it out. Otherwise, like that's not a big issue. I mean, if there is any calculation mistake here and there. So we will be solving some questions. If there is any calculation mistake, you can just comment it out. Okay, cool. Now let's just see that from here how to convert this particular minus 2. Below of this to 0. So what you can do, you can just write. That R3 can be replaced by. See, you can multiply minus 2 here, and you can multiply minus 3 here, which means minus 2 R3, and then you can multiply minus 2 here and minus 3 here, which means minus 3 R2, and then you can subtract both of this. So if you subtract both of this, which means actually it is just a plus. Okay, so you can write plus here, and then let's just check. If you multiply minus 2 here, it will be 6. If you multiply minus 3 here, it will be also 6, and that is why you can basically, if you multiply minus 3 here, it will be also 6, and then you can subtract both of this. So I think this will work, right? Cool. So what will the final answer you will be getting? Let me just write here. See, you can do all of this here, which means you can write some constant here. If this is Ri, then you can generally we will be writing Ri plus KRJ. But here we are writing some constant. I mean, in this set of linear equation, we can write some constant. Reason being is that it won't matter. But in case of determinant, you have to be very, very careful. Okay. So now what you will be getting is this. It is 1, 1, minus 1, and then 0. And then this is already 0, minus 2. This is 2. This is 2. And then let's just see what you will be getting here. So it is already 0. Then you are replacing R3. So that's why this is 0. this 1 will be multiplied by minus 2. So minus 2 plus 3 are 1, which means this will be 6. So it is actually 4. So we will be writing 4 here. Similarly, minus 3 into minus 2, it will be 6 plus 3 are 2, which means this is also 6, right? So you will be getting 12 here. So that is the final matrix that you are getting. Now, let me just do one thing. Let me write this final matrix on the next page. So we started with we started with this matrix and we finally got this matrix, right? I hope you understood the idea. Now let's just see what we can do from this final matrix. So our objective is to solve system of linear equations. So let's not worry about all of this, like what we did in between. I have already copied it, don't worry. But yeah, what we did in between, that is okay. But we started with this set of equations and finally we got this set of equations, right? Cool. Now our objective is to solve for x1, x2, x3. So what we can do from here such that I am solving for x1, x2, x3? See, this set of equation, can you just rewrite it in the set of equations? If you just see the last line, the last row is actually 4x3 equal to 12, isn't it? The last row is 4x3 equal to 12, which means from here you can say x3 is actually 3. Very nice, right? So from the last row you can directly get the x3. See, the idea here is that you start with this set of equation and we are saying that this set of equation can be represented using this matrix, and instead of juggling with these set of equations, I am doing the elementary row operations on this. And then finally I got this. I am saying that this is the simplified form of my this set of equation, which means this set of equation, corresponding set of equation, you know, right? Which means it will be like, if you write the first equation, it will be x1 plus x2 minus x3 equal to 0. The corresponding set of equation you can definitely write. And I'm saying that, and similarly for this line, you will be saying that minus 2x2 plus 2x3 equal to 2. Whatever, right? Actually, it is not important. That's why I'm not writing. Basically, the corresponding set of equation you can definitely write. And what we are arguing is that whatever the set of solutions here exist, the same set of solutions here also exist. Reason being is that I just applied the elementary row operation. That is just plus minus of some equations, right? So I haven't done anything wrong. So that is why the set of equations, the set of solutions here are similar to the sort of solutions here. So okay, the x3 equal to 3 is one solution. I mean, you got the final value of x3, which is 3, and then let's just see if we can get x2 also. So the idea here is that we will be starting from the back, which means the last row, and then just pick the second last row, which means minus 2x2 plus 2x3 equal to 2. But now you already know the value of x3, which is 3. So you plug in this 3, then you will be getting minus 2x2 plus 6 equal to 2. And then from here you will be getting minus 2x2 equal to minus 4. So x2 will be just 2, right? So x3, let me just maybe write the answers here. So x3 you're getting as 3, x3 is 3, x2 you're getting as 2, right? And then just pick this equation lastly, which is x1 plus x2, but x2 value you already know, minus x3, that is you already know, equal to 0. So it is minus 1 and x1 is actually 1. So from here you got the answers. So from here you are saying x1 is 1. Right? The x1 is 1 and x2 is 2 and then x3 is 3. So that's how you can solve this set of equations. I hope you got the idea. What we are doing, we are starting with this set of equations. We are saying that, okay, let me represent with this a matrix. I will convert that to equivalent matrix. And what is the use of this equivalent matrix is that I can directly solve for x3. And once I directly solve for x3, I can directly solve for x2, and then I can directly solve for x1. This is also called back substitution. See, if I'm not writing something on the slide, that definitely means that it is not important at all. So so don't try to write everything whichever I'm saying. Okay. So if I'm not writing anything on the slide, then just be happy because it is not important at all. Cool. So yeah, so these are the final answers that we have. So I also have the solution in the typed format. If you want, you can just refer to it. Okay. Now, let's just do one thing. Let's just solve this equation. So I just request you to pause this video and just solve this set of equations, then just unpause this video. Okay, so now let's just solve this. See, there are two variables, x1 and x2, which means there will be just two columns, right? So you will be writing two columns, which is basically 5 minus 11, and there will be column for the augmented vector, right? Okay, this is minus 4, 9, and 1, minus 2. And then you have minus 2, here you have minus 2, 1 and 1, minus 1. Now we need to make all of this a 0. Let's just do it. Okay, one thing I just noticed is that this is 1 here, right? I mean, calculation with 1 is actually little easy. So why not to write this 1 here and why not to write this 5 here? So just because the calculation is easy with 1. So let me just, interchange these two rows. There is no particular reason, but it is just that calculation with 1 is very easy. So it will be 1 minus 2 minus 1, and it will be 5 minus 11 minus 2. And then let's just make these zeros. So if you want to make this 0, this is R2. You can say that R2 should be R2 plus 4R1. And then if you want to make this 0, I mean this 5 0, then this is R3 minus 5 R1, right? Cool. So let's just do one thing. Let's just go to the next page and solve this particular set of equations. So you will be getting, after this you will be getting, let me just a second. Okay, so after this you will be getting a matrix where you will be having zeros below this 1. So this is the matrix that you will be getting, where 1 minus 2 minus 1, this will be 0. And now R2 plus 4R1, which means 9 plus minus 8, which means that it will be 1. And then R2 plus 4R1, which means it will be minus 3. And then it will be 0. And R3 minus 5R1. So minus 11 minus 5R1 means plus 10. It means it will be 1 minus 1. And minus 2 minus 5R1 means this is 5. Then this will be 3. Right? Okay. So these are the values we are getting. Now let's just see one thing, that how can we make this 0. So I think you can easily make this 0. How? You can just do R3 should be going to R3 plus R2, right? So by this you will be getting the final matrix, which will be something like this. This is 0 1 minus 3, and then 0 0. Okay, this is also 0. Great. So you are getting this as final matrix. Now just notice one thing, that we started with something and then we got with something else, right? Cool. So let me go to the next page, and this is the final matrix we are getting. So what we started with this matrix, and we got that as final matrix. So let me put both matrices side by side. So we did something and then we finally achieved this. What does this mean? It means that whatever set of solutions are here, the same set of solutions are also here, which means if I can solve this, I can also solve this. I mean, all the solutions satisfy the same set of equations, because this is also set of equation, this is also set of equation, and same solution satisfy both set of equations, because I just did some elementary row operations, right? Okay. Now let's just see that how we can solve it. If you remember from the previous example, we were doing the back substitution, which means we were first solving this, then solving this, then solving this. So let's just solve this last line. If you convert this last line into equation, it is 0 equal to 0. This is very trivial fact. I mean, this is I can say some useless information. I mean, 0 is actually 0, so it is not giving me any input. So I am not able to detect. I am not able to compute any value from here. So that is why I will say that this is just useless. I mean, you are not coming up with any value from using this. That is perfectly fine, not an issue. So if you remember, this was corresponding to x1, this was corresponding to x2. Now let's just solve this. For this, you will be getting x2 equal to minus 3, and then you can put the value of x2, which is minus 3, in the above equation, which is x1 minus 2x2 equal to minus 1. And then from here x1 equal to, this is minus 3, so it will be plus 6, but minus 1 minus 6, then finally minus 7 will be the answer. So x1 is minus 7, x2 is minus 3. That is the final answer you are getting. Okay, very easily you can solve this set of equations. I hope you understood. Now let's just go to the next problem. So see, in this problem they are saying solve the following set of equations. So these set of equations are given. So how many equations are there? 3 equations. It means there are 3 columns. I mean, there are 3 variables. That means that there are 3 columns, right? So first column is corresponding to x1, and then this is 0 0. Second column is corresponding to x2, which means this, because there are x1 and x3 coefficients are 0. Third column is corresponding to x3, which is this. Now let's just write these variable, this vector, which is 6 5 7. Now it is already in the echelon form, so you don't need to do anything. You can just finally get the answer. This is 4x3. This is 4x3 equal to 7. So from here x3 is equal to 7 by 4. Similarly, this is 2x2 equal to 5. 2x2 equal to 5. From here x2 is equal to 5 by 2. Similarly from here you can say 3x1 equal to 6, then x1 equal to 6 by 3, which is 2. So that's how you can get 3 answers. Actually for this particular question you don't have to do all of this. They have directly given the answer, right? I mean from here directly you can calculate the value of x1, from here directly you can calculate the value of x2, from here directly you can calculate the value of x3. So you don't need to do all of this, but anyway, like you can solve like this also. It is just an extra step that we are putting, right? Okay. Let's just solve these set of equations. So here if you want you can just pause this video and solve this question. So here let's just try solving it. It is 3 5 minus 4, and then okay, this is 0, this is minus 3 minus 2 plus 4, this is 0, 6 1 minus 8, and then this is 0. Now let's just make few of the values 0 below this 3, right? Okay, so below this 3 let's just try to make the value 0. Now what you can do, you can apply some elementary row operations, which will be something like this: r2 plus, maybe you can just say r3, I think it will make it 0, and for r3 you can say r3 minus 2r1, right? Okay, so let's just do it. Maybe I can minimize it little bit. So here what you will be getting is something like this, which is basically you are not changing anything in the r1, so it is as it is. You are changing it, this is 0, r2 plus r3 means this will be 3, this will be 0, this is 0, and then this will be 0 because r3 minus 2r1, right? So 1 minus 10, this will be minus 9, minus 8 minus 2r1, which means minus 8 plus 8, it will be 0, right? Okay, so you got this. Now let's just do one thing. Let's just see if I can make other parts also 0. So if you want to make this 0, which means you need to apply r3 should be going to r3 and maybe plus 3 r2, right? I think this operation can make it 0. So now here this is 3 5 minus 4, and then 0 3 0. Okay, these are zeros, 0 0, and then this is 0. Okay, so this is minus 9, and then if you do r3 plus 3 r1, this will be 0, and then r3 plus 3 r1, this will be 3, and then ultimately this is r3, sorry, this will also be 0, and then this will also be 0, right? So finally you got this. Now let me do one thing. Let me write this matrix on the next page, or maybe let me write both of the matrices that we have got on the next page, right? So these the matrix that we started with and the final matrix that we have got. So this is the matrix that we started with, and this is the final matrix that we got. Now we are saying that both are sharing the same set of solutions, right? So this is our argument. Now let's just do one thing. Let's just try solving it. So if you recall, there were three variables x1, x2, x3, which means now here you can say this corresponding to x1, this corresponding to x2, this corresponding to x3. What are the pivot variables, by the way? I mean, these are the three variables that I completely agree, but I think x1 and x2 are the pivot variables. Okay, x3 is free variable. Cool. I think this is the first example where we are having the free variables. Otherwise, I think in earlier examples, let me just check. I think all the variables were pivot variables in the row echelon form, right? So this is the row echelon form that we have got. So see, you have the pivot in every row, which means every variable is a pivot variable, right? You have pivot in every column, which means in this column there is a pivot. This column is also having the pivot. This column is also having the pivot, which means you are having the pivot. Every variable is a pivot. Cool. Okay, so I think in this example also, whatever you have got, okay, you finally got this, and then these two are the columns which are the pivot columns. So there is no free variable here also, right? Cool. So there is no free variable here also. I think these three are the variables x1, x2, x3. I mean, this is x1, x2, x3, and all are the pivot. Cool. Yeah, I think this is the first example where we are having x3 as a free variable. So whenever you have the free variable, you cannot compute the value of x3 using this equation, because this is just a trivial fact, which is 0 equal to 0, which means what? It means, I mean, if I write in terms of x3, it will be x3 into 0 equal to 0 or something like this, right? Okay, so basically it is actually a trivial fact, and this x3 is not, I mean, you cannot compute the x3 using this equation, right? And x3 is a free variable. So whenever you have the free variable, just remember one thing: the very first step, okay, this is very first step, is basically identify the free variable and the assign any like constant to that. So identify in the free variable and assign a constant. Constant means like a parameter, a constant parameter, constant parametric form, which means k, t, something like this. Not like 2 or 5. Okay, constant parameter. Let me just say parameter to that. Which means what? That here, as you have identified that x3 is a free variable, then you just assign the value of x3 to be k or t or whatever you would like to assign. Okay. So let me just say that x3 is a free variable, and then that is why x3 is k. This is the first step. Okay, you need to identify whether you have the free variable or not. If you have the free variable, just assign that value. This is the very first step that you have to do. Now x2, you can compute the value of x2 using this equation. So you can say 3x2 equal to 0. It means that x2 is equal to 0. Now you can compute the value of x1 from here. How? You can say 3x1 plus 5x2 minus 4x3 is equal to 0. And by this time, you know the value of x2 and x3. x2 is 0 and x3 is k. So that is why you can say this is 3x1 and then this x2 is 0. So it is 0. And then this is k. So minus 4k equal to 0. From here, you are getting the value of x1, which is 4 by 3k, right? 4 by 3k. I hope you understood that how we are calculating the value. Now you got the values of x1, x2, x3. This is x2, this is x3, this is x1. Now let me write the vector x. Okay, so let me write the vector x. Let me just tell you that how to write the vector x. So the vector x will be, the final solution, vector x means the final solution will be just x1, x2, x3. And in this case, okay, let me further minimize it. In this case, it will be x1 is 4 by 3k, x2 is 0, x3 is k, right? So this is the final solution you have got. Like people generally like to take this k common, so you can just write something like this, right? So this is the final solution you have got, which means that this kind of solution satisfies the equation that you have. So whatever the equation earlier was there, let me just copy the equation and the solution all together. So I think this is the equation that we have. So let me just copy this there only. Yeah, in just a second. So this is the equation and this is the solution, final solution that we got. So these are the x that satisfy. Now as you can see, this is not just one x. So this is the beauty about this answer, that there is not just one x that satisfy here. These are the many x. So if you put k equal to 1, then you will be getting x equal to, I think, 4 by 3, 0 and 1. If you put k equal to 2, then you will be getting, or maybe any other value, let's suppose minus 2, then you will be getting x equal to other values, minus 8 by 3, 0, minus 2, or something like this, right? So for different values of k, you will be getting different values, which means there are infinitely many solutions, and every solution, like this solution, every solution satisfies this set of equation, right? Which means you put 4 by 3, 0, 1, I'm 100% sure that it will satisfy these three equations. If you put minus 8 by 3, 0 or minus 2, I'm 100% sure that this will also satisfy these three equations. So there are infinitely many solutions. Right? So this set of equations that we currently just solved, it is having infinitely many solutions. But now you may ask me next question that, okay, there are infinitely many solutions which look something like this. Then how many are linearly independent? See, there are infinitely many solutions that I completely agree, which means for k equal to minus 1, you will say this is one solution. For k equal to plus 1, you will say this is another solution, right? For k equal to 5, you will say this is another solution. But how many of these are linearly independent? If I just ask you that how many of these are linearly independent, then what is your answer? See, there is only just one vector which is linearly independent, which means all other vectors are linearly dependent on this vector, or any vector, like all other vectors are linearly dependent on this vector. So if someone asks you that how many solutions are possible, then your answer is infinite. Okay, that's very important. Your answer is infinite. But if someone asks you how many linearly independent solutions are possible, are possible, then your answer is just 1. Okay, so that's the difference. So only just one linearly independent answer is there, but there are infinitely many solutions. Earlier, I think this is the first case where we have infinite solution. Earlier, I think there was just one solution, right? So in any other question that we have solved, so this is the x1, x2, x3, just one solution, I think. In the second question, I think everywhere this was just one solution, right? So this is just one solution that we are getting. The reason is actually very obvious here. If you just notice that what is difference between earlier questions and this question is that here you have the free variable. So whenever you have the free variable, right? Whenever you have the free variable, you will be putting the value of that free variable in the parametric form, which means you have put this value as k, and it immediately means that there are infinitely many solutions. So if there is a free variable, right? If there is a free variable, then there are infinitely many solutions. If there is no free variable, then there is either solution or I mean either unique solution or no solution. Anyway, we will talk about no solution case later, because till now we have talked about unique solution. We have talked about infinitely many solutions, but yeah, we will talk about no solution also. I mean, talk about means like we will solve the questions where you do not have any solution. But what I want to convey here is that if you have the free variable, then you will be having infinitely many solutions. Because this free variable can take any value, and that is why there will be infinitely many solutions. And that's very, very obvious that you cannot write the infinitely many solutions just like the set notation. So that's why this is called a parametric notation, which means you multiply some parameter and then you have the parametric notation where you represent all set of solution in just one line. And if someone asks you that how many linearly independent solutions are there, then you will say just one solution. I hope this is okay to everyone, right? Now let's just solve more questions, and don't worry, we will come back to these things again and again. Like, I mean, I will make sure that this is very, very clear. It is just introduction to these few things, but I will make sure that these things are very, very clear. Let me solve a few more questions for now. Okay, so let's just solve this question. This is question number 5, I think. Now here, what they are saying, solve the following system of equations. So for that, what we need to do? We need to just write these set of equations in the augmented matrix, which will be something like this, which will be 1 minus 3 1, and then it will be 4 minus 1 2 minus 5, this will be 3 5 minus 13 plus 13, this will be 8, right? Okay. Now let's just try solving it. I can copy this on the next page, I think. And then I want to make these as zeros. So I can say that R2 is basically R1 plus R2. I can say R3 is R3 minus 5R1, right? Okay. So from here, you will be getting 1. I think I can write it here only. So you will be getting something which is 1 3 1, 1 minus 3 1, and then 4. And then you will be getting 0. Then it will be R1 plus R2, right? So it will be minus 1, minus 4. Sorry. This will be 7, R3 minus 5R1, right? So it will be R3 minus 5R1. So I think it will be 5 minus 5, it will be 0. R3, which is minus 13, plus 5R1 will be plus 15. So it will be plus 2. And then R3 minus 5R1, 13 minus 5, this will be 8, right? So this is 8. And 8 minus 20, this will be minus 12. This will be minus 12. Okay, so these are the values that we are getting. Now let's just further make this into echelon form, which means like I will be making somehow this also a 0. So to make this also a 0, you can put R3 as R3 plus 2R2, right? And then finally you get some matrix which should be in the echelon form. 1 minus 3 1, this will be 0 0, minus 1 minus 4 7, and then this is 0. R3 plus 2R2, which it will be 0, right? And then 8 plus 2, it will be also 0. And then it will be minus 12 plus 14, this will be 2, right? So finally you got this answer. Okay, so let me do one thing. Let me write the final answer on the next page, or maybe the one we started with, and then finally what we got, right? So yeah, let me write it on the next page. So we started with something like this, and finally we got something like this. Okay, I hope that's fine, right? Cool. Now let's just try solving for x1, x2, x3. So this is what we got after few elementary row operations. Cool. Now let's just try solving for x1, x2, x3. Now to solve for x3, first let me check. Okay, these are x, y, z, right? Okay, so this is x, this is corresponding to x, this is corresponding to y, this is corresponding to z. Now let's just solve for the back using the back substitution. Let's just solve for the z. So you will be having, using this last equation, you are saying that you are having 0 equal to 2. Oh, that's a problem, right? Because 0 is not equal to 2. Then what does this mean? It means there is something wrong, right? Which means whenever you are trying to solve this question, you got to encounter one equation which is saying 0 equal to 2. So it means there is no solution, which means this set of equations simultaneously are saying, if you put those set of equations simultaneously, they are saying 0 is equal to 2, which is false, right? Which means those set of equations cannot be solved simultaneously. I mean, there is no solution to those set of equations. So this is the first example we are getting where we are saying there is no solution at all, because we are getting 0 equal to 2. See, the reason why we are saying that there is no solution, because this is the first time I got something which is not true, right? Earlier I was either getting 0 equal to 0 or I was getting something which was solving my x3, right? But here I am getting 0 equal to 2. So it means there is no solution at all. No solution. I hope you understood this particular problem. Why there is no solution? Because in the last I am getting 0 equal to 2. So see, let me just recall you that what we are doing. We have solved this example. In this example, we got unique solution, right? We got unique solution, and everywhere we got unique solution until and unless we encountered one question which is having the free variable, right? So I think this is the first question. This is the first question, question number 4, which is having the free variable. It is having the free variable. So question number 1, 2, 3 were unique solution. Question number 4 is infinite solution, and question number 5 that we have solved is actually no solution. So we have actually like solved 5 questions. 1, 2, 3. Unique solution. Question number 4 we have solved, is it was having infinite solutions, and question number 5 we have solved, it was having no solution. So there are 3 cases like in the system of linear equation, and we have covered all the 3 cases using the example. Now there is very interesting thing that you need to observe, which means like I help you in one thing, which is that when there is infinite solution, whenever there is a free variable, like when is infinite solution, whenever there is a free variable. But I will just not worry about infinite and unique. I'm just clubbing into that. Okay, solution exists. Okay, solution exists. I mean, either this is unique solution, infinite solution. Let's not worry about it. I'm just clubbing these two kind of pattern into just one pattern. I'm saying, okay, here the solution exists and here the solution doesn't exist, right? So these are the 2 patterns that two set of questions you can consider, where I'm saying that here the solution exists and here the solution does not exist. Now what we need to do, we need to just argue this. I mean, we need to just figure out some argument or some logical statement where I can say that, okay, this kind of thing is existing, that's why the solution exists, or this kind of thing is existing, that's why solution does not exist. I mean, see, solution does not exist here. Why? Because 0 equal to 2, right? But let's just do this more in the more formal way. So if I just ask you that why sometimes solution exists or sometimes not, then you need to answer this question. Okay, and you can also solve this particular homework question. I think this is the one homework question that you can solve. Okay, let me just remove this. So you can solve this particular homework question, and then once you solve this question, then also answer this particular question, which is very, very important, very, very, very crucial, which is saying that why sometimes the solution exists and sometimes not. So we have solved, as I just told you, we have solved 5 questions. Sometimes solution exists, sometimes solution does not exist. Now let's just see why solution sometimes exists and sometimes not. So just let me know what is the answer you have got for this homework question in the comment, so that others can also verify. Okay, and then if you are interested, then also comment out the reasoning behind this particular statement, that why you think sometimes solution exists and why you think sometimes solution does not exist. We will answer this particular and very crucial question in the next video. Okay, thank you so much.